I do want to introduce Kurt, who's the author, not begrudgingly, but happily the author, and Maila, Hallare, who's at the Air Force Academy, and they've been using the textbook, and AJ Alnaser from, and I also see Justin Hoffmeyer, but AJ was on the program, who's been using it at Florida Polytechnic University. So I'll turn it over to maybe Kurt, if he wants to talk about his general philosophy and maybe hear from the user's point of view.
Yeah, I thought I'm just show 2 slides for anybody who's not familiar with the book, and then Maila and AJ can chime in with their experience on the book. And I got lots of questions, and anybody else who wants to. So let me share my screen briefly. And so can you see that?
Yes, we can.
Very good. All right. So the motivation for the book, like Brian said, he came to me, asked me to write a book, and I learned from him, and I decided that modeling and applications for ODEs right up front to motivate why we're studying the subject is it's important. It makes it more meaningful to the students. But the goal is not to replace the mathematics, but to put it in context and say, here's why we're doing what we're doing. The applications are the hook for the ODEs, and it helps students see the effectiveness of ODEs. And especially I admit I wrote it for the students I've been teaching for 30 years, who are all STEM majors, but I wanted them to see why ODEs are important and they should pay attention. And I wanted to incorporate, I spent a lot of time in industry and government labs, and I wanted to throw in topics I thought were important for people to know to the extent that you can work it into a course. So things like dimensional analysis, scaling in ODEs, estimating parameters. I threw in a little control theory, and then as much data as I can get my hands on for assessing whether the models are any good or how they might be improved. So the text incorporates a lot of SIMIODE modeling projects that were adapted for the book. I also made up a number of new ones, about half and half. All the data sets I could get my hands on, and I'm still collecting data sets for future iterations of the book. I always found this useful in textbooks. I put in little inline reading exercises that are quick, just 30-second to 2-minute exercises to engage the reader and keep them on their toes before they proceed. But then I put in the traditional end of the section problems. And then, like I said, a lot of modeling projects at the end of the chapter. Every chapter has 3 to 6 modeling projects at the end. And on the CUBES SIMIODE website at CUBES, there's complete sets of solutions, at least if you're an instructor. And there is also an ally at that location. I wrote about 35 programs, computer programs, to support the book. Each program comes in Maple, Mathematica, MATLAB, and Sage. So those are all freely available to students. And for what it's worth, there will soon be an online HTML version of the text. It's already created. And over time, we hope to work in interactive features like the ability to call Sage code from the text. So that's sort of a quick background on the textbook. So I guess what I'd like to throw. I know Maila and AJ used the book. I don't know what can you give any insight? How'd your students respond to it?
So if would Maila like to go first?
Yeah, is that okay?
Yeah, please go ahead.
Yeah.
Okay, so I created a short PowerPoint.
Okay.
Now I feel completely unprepared. I didn't create PowerPoint.
Wait, what is wrong? Are you seeing my screen?
Yes.
Yeah, just go to
Okay.
full screen.
Okay. How about that?
That's good.
That's great.
Okay, so We started using the SIMIODE textbook last semester, fall 2023. But prior to that, around spring of 23, I became very anxious when I learned that I was going to be the course director of this Math 245 course. And so I did a lot of reflection. I did a lot of search. And in the end, I found this paper by Giancarlo Rota, an MIT professor. His specialty is really combinatorics, but this is one of his articles on 10 lessons I wish I had learned before I started teaching differential equations. And so as the course director, I made all of my instructors read this paper before the start of the semester. And so these were his guidelines. He said that most of the material that are being taught in ODE courses are obsolete. He suggested reducing the discussion of first-order differential equations at the beginning of the course. I don't quite agree with that. Number 3, he said that linear differential equations with constant coefficients are the bottom line. So basically, Rota was saying that we should not teach like those techniques such as exact differential equations, or like all of those substitution techniques for homogeneous first order differential equations. A little bit more. Teach change of variables. Forget about existence and uniqueness of solutions. This one I adopted because I wanted to save time and focus more on some applications. Linear systems with constant coefficients are the meat and potatoes of the course. That is true. I have spoken with many engineering professors, and they told me in many different ways that they would like the students to really know second order constant coefficient and all the damping cases, overdamp, underdamp, critically damped. Stay away from differentials. I don't quite believe in that because the only integration technique that we taught our students are like the separation technique, which uses some differentials. But yes, in some parts we don't do the differentials approach like what we saw in calculus. Final tips from Rota: avoid word problems. Well, I did not do that. Motivate the Laplace transform. And so in the end, I had to choose between 2 textbooks. The one on the right by Zill is what we have been using at the academy. But there were many things that I did not like about it. And so in the end, I chose the Scudem. I chose the SIMIODE textbook because this is one of the reasons, Kurt, and I'm glad that you did it, is that the approach is first order differential equations and then second order and then system of first order differential equations. In the Zill textbook, they introduced system of first order differential equations like right in the first or second chapter. And because I was hearing the engineering professor's request to focus on the second order. So at the academy, what I did was I divided the entire semester into 3 blocks: first order, second order, and then system of first order differential equations. So I will be quick on this part. So I always believe in having a very strong first day of lecture. And so right from the start, Section 1.1, the Hill-Keller model.
Hey, that's what I start with.
Yes, this is all from your textbook. So right from the start, we have this table. And then previously, in my previous institution, we did not have MATLAB. So I was basically using Excel and Excel's solver to do the data fitting. But now that we have MATLAB at the academy, I mean, all cadets have MATLAB in their instruments, in their laptops. I use the MATLAB's curve fitter. So I created, for example, a video on how to use MATLAB's curve fitter. And so I used the data that you have in the textbook, and then basically they do a curve fitting like this. And the students like this because before going to a differential equations course, all of our students at the academy have some experience with data fitting using RStudio. But starting from differential equations onward, all cadets, especially the engineering students, are required to be some sort of experts in MATLAB before they graduate from the academy. And so right from the start, we do a lot of MATLAB things, like the curve fitter here. So this is my PowerPoint for lesson 1. I will stop sharing that, and I think I have some other things here. Well, I also like, Kurt, that you are using some units like liters, not just pounds, because I am sometimes confused with pounds, pounds and gallons. In your examples and exercises, it was about liters and yeah, but you were using Fahrenheit. Anyway, let me just share one more thing. So at the academy, we also, well, in class, screenshot from your textbook. Exercise 2.17. This is a salt tank compartmental modeling problem. And so in class, this is what I'm saying, that I still believe in word problems. So we talk about the theory, and then we solve problems like this. And then we like to solve this using MATLAB's DSolve, for example. In this case, it will be a concentration of 0.2 times 4 minus A over 400 times 4 out. Okay, and then we will do a DSolve. And so even though our students will be DSolve, ODE, even though our students will be doing a lot of word problem solving, I emphasize that they have this MATLAB tool to help them solve the differential equations, and so that we don't spend a lot of time on the algebraic parts of solving a differential equation. So this is using DSolve. And then yeah, so throughout the semester, we do a couple of curve fitting, lots of MATLAB using DSolve, and then when it's time to talk about Laplace, I integrate MATLAB in many other places.
Okay, that's great. AJ, what do you think, Florida Poly? Without slides, you're okay.
Okay. Well, actually, when I first got introduced to the textbook and SIMIODE and all that stuff, my first task was to convince not just my colleagues, but since differential equations is really a service course for all the STEM majors. So most of our students like we have, let's say 120, 130, somewhere between 120 and 150 students per semester in differential equations. I would say 20 of them, maybe between math and physics, and the rest are engineering. And we do have the odd computer science major that likes to take differential equations, just like the extra math. Part of what I started with is like, okay, how do I convince everybody else that I'm going to throw away the traditional way of teaching differential equations, which is just grind more techniques that students never retain, and bring in this modeling approach. So I actually do have slides that I actually wrote up so that I can convince the other chairs, and actually ran these slides in our own math department. But everybody got I mentioned that, well, students don't retain anything from differential equations the way we teach it, so why not change? Everybody was, okay, I'm sold, let's go move on, let's change. So we don't really, we have a culture at Poly where we really don't have resistance to change. We change things all the time. So we adapted Kurt's book, and Kurt was kind enough to actually come and give a talk that was very well received. By the way, I still use representation in my class. I show, like, because we don't have time to dig into control that much. So I actually drop your slides on my course and say, hey,
Okay,
you learn about control, read these. So that's a really good example that students like and love. Like I said, I really don't have that many slides that I want to share with you, so I'm not going to take too much of your time, but I do want to share some of the comments that I'm actually, we surveyed the students after teaching the class, and we had some comments, and a lot of comments were, I really enjoyed modeling. It was great overall. I had a lot of fun with learning about the intricacies of differential equations. These kind of comments are foreign language, like if you compare it to the old comments we used to have in differential equations. So students love that. Students do find the book a little bit different. But we started transitioning students in Calc 1 and Calc 2 as well. So now by the time they get to differential equations, they already understand separable and linear. They know about phase diagrams. They know a whole lot of stuff that we can just move quickly in differential equations and get to the meat and potatoes. We do start with modeling. We spend a lot of time in modeling. Pretty much every problem we do in class is a story problem. I very rarely throw a problem that's just a plain old differential equations on the board and ask the students to do it. I only do that every once in a while if I feel like they need some reinforcements on techniques. Just a little bit of grind every once in a while is not a bad thing. I do think the algebra and the calculus is very important, and we need to kind of reinforce it, so that they don't leave the stuff they learned in the calculus sequence back in the calculus sequence. They need to retain all that information and take it forward. We use MATLAB heavily, and we decided that we want to emphasize modeling even more. So what we did, and Justin will keep me honest on this, we designed 6 labs where we actually run the labs in class, and the labs are essentially just either practice solving differential equations in MATLAB. That's the first lab only, where we introduce students to MATLAB. A lot of our students don't have experience with MATLAB before differential equations. And depends. It's really a mixed bag, but there is no uniformity at all. So we don't really know. So what we see from the surveys we run is a lot of them had heard of MATLAB, maybe used it once, maybe to run a picture or multiply 2 matrices, but never to solve differential equations. So they see how to do that in the first lab, but then we get into second, all the way through the 6th lab, where essentially it's all modeling. In the second lab, they run through several variations of the mixing tank model, for example. They see several stories. All of them can be modeled with the mixing tank model. They just need to modify the model to fit it. So they get more experience in modeling. We did have actually a couple of suggestions last semester of asking, students are asking for a project where they get to go out, create their own scenario, model it, gather some data and analyze it. They want something like that instead of a final. And I'm not really against that, but it's something that needs to be thought of and prepared well. And I'm not the only person teaching the course, so we need to make sure that everybody's on board when we make a shift like that. All in all, we've had great success, I can say. Our average on standard assessments like midterms and final, we used to average around in the C range. Now we're averaging somewhere between the B plus A range for the students, and that's how they're scoring. We modified the problems very little, but it's essentially the same type of exams we used to ask them. So we used to grind them on techniques and ask them technique questions, and they would average a C grade. Now we don't grind them on techniques. We just teach them what the techniques are for, and we still ask them on the exams for techniques, and they manage to do better. And the reason why we haven't changed the exam a lot is because we have learning objectives that are approved by university, and it's a bit of a hassle to change everything. So we have the learning objectives, and we're still assessing the learning objectives. Okay, and the same learning objectives are still the same. We modify them a little bit, but we still assess the same thing. Can you solve a linear and separable? Can you solve a spring mass system? Can you apply Laplace transform? Things that are very technical, very easily assessed on an exam, and students are doing way better just on the assessments themselves and overall. So we've been we've been doing very well with the book. We love it. We're kind of digging into now creating more variations of the labs we created. Some of the labs, like I said, some of the labs handle modeling. Some labs actually take on the projects and I think we used two, if I remember correctly, out of the straight up out of the book.
2 of the projects, you mean?
To the projects as
Okay.
labs. We used
Okay.
I think the shock absorber example, the shock
Okay.
absorber project. We created
Yeah.
a lab around it. And we used another one, and memory fails me right now, but something from chapter 5. I remember something I was using
Okay.
Laplace transform. We used stuff that's from the book right away.
Okay. So both of you used MATLAB in your courses. Can I ask, was any of the software on the website useful?
Oh,
Did
very
you
much.
use it or the students grab it?
Yeah, very much so. I actually downloaded a lot of the softwares, mostly MATLAB. I downloaded most of the MATLAB codes, and I actually post them on Canvas. That's the platform we use.
Okay.
And like basically I refer my students to them. I tell my students, okay, well, here are some of the resources that you can use. So I don't dictate a source. I recommend MATLAB. Our labs are built off MATLAB because that's kind of what's commonly used in engineering.
Yeah.
But I don't limit that. I told them, here are the sources. Here's some codes that I got from the author himself. So they're right here. So, and a lot of the students just download them and use them. And we see that in their assignments when they turn in their assignments.
Okay. Maila, did you give out the software?
Yes, we use MATLAB.
Okay. And you used the stuff on the website?
Oh, yes,
Useful?
yes.
Oh, okay. Okay, good.
Thank you.
Yeah, thank you for those, by the
That
way.
was
They're
very
incredibly
helpful.
Okay, good. I didn't waste my time writing all that.
Oh, no, not time well spent, my friend. Time well spent.
I
can agree with
spent
that
the whole
one.
summer of 2022, right? Going right at Maple, switch to MATLAB, switch to Mathematica, switch to Sage, and just did that round and round and round all summer.
Yeah, I wouldn't be able to do that, and I really appreciate you spend the energy to do it for me. It's been incredibly
I
helpful.
almost threw Python in, but it doesn't really have symbolic. Sage is basically built on Python, so that
Yes.
there was no need.
But for the face portraits, you had Quiver. Instead, I told my students they can use the pplane.jar from Paul King.
Okay.
Yeah, I'll type it in the chat. Pplane.jar.
Okay.
Any other contributions, knowing that at the end of this evening from 8:30, we have 2 sort of open discussion rump sessions, one on AI, if you want to continue that, and the other one is related to this textbook. So SIMIODE is unabashedly pushing modeling first, and this textbook is exemplar in that case. So we'll revisit that. But right now, I'm going to be leaving for now. And I want to thank AJ and Maila for leading on. Justin Hoffmeyer is at Florida Poly as well. So you're welcome to continue this conversation. And the last one out will essentially close the door. We won't have the discussions from here on out recorded. It's the formal session. So again, I really thank Kurt for doing all the work, and we're getting the hourly wage up to about $1.25 now for the book. So we're moving, in the right direction. But thank you very much, and we will see you in another session. Take care.
All right.
I'm
For what
just
it's worth, I'll be back at 8, whatever it is, 8 o'clock or whatever.
and you can stay on and talk. I
Yeah.
just got to leave.
Okay. Okay.
I did hear in Kurt, if you have a few minutes, I did hear you.
Yeah.
While I just logged in and you were talking about the web-based version. I think that would be very welcomed in, at least for our school. I think I only saw, we've been using your book for what, 2 years, 3, 2, almost 4, at least 4 semesters now. I only saw maybe 2 or 3 students buy the actually printed edition, or at least bring them to class. But I see a lot of the students pull your book off their phone or off their laptops and ask me questions.
Yeah. Yeah.
So it's the electronic version has definitely been more used, at least by our students. That's what I perceive.
Okay. Yeah. So the HTML version is done. In this, but all it needs is to be fine-tuned and have someone proofread it, make sure everything looks good. And the goal is, right now it doesn't have this, but the goal is to eventually work in some interactivity, like where it can call Sage inline, and students can run stuff inline on the HTML version, which I know how to make that work. So just got to get that ready to go.
Oh, yeah, that'll be great. The other thing is, I was going to mention also that in terms of graphing utilities and stuff like that, if you can make it interactive, if there is a way to make those interactive, like we can use Desmos. Our students love using Desmos for
Yeah.
pretty much everything.
I don't know how I can call that from the HTML. Maybe I can, but like Sage, I can make a call to a server somewhere else. So you don't need local installation. So I don't know, I have to figure that out and see what's possible.
Yeah, the other thing is a lot of students have been asking about solutions to the reading exercises.
That's completely available to them.
Yeah, so and I told them that's fine. You go, it's on
Go to
SIMIODE.
Cubes.
Go find it, and it's perfectly fine if you go look for it. I don't personally share it with them because I want them to actually spend the energy and go look for it.
Okay.
But I think the reading exercises have been an incredibly useful tool for us.
Now, in the HTML version, the reading exercises have the solutions in line, where it's a little link and you click on it and expands it and shows you the solution.
Oh, yeah, that would be nice, but this way we can't ask them to do it on homework anymore. So let's just stick with it and just
Yeah,
copy that.
well, yeah. But the reading exercises, the intent on the reading exercises was always that it's available, the solutions are available to the students so they can check their understanding right away as they're going. And then there's plenty of stuff at the end of the chapters to.
Yeah, just like I like assigning them reading assignments. So when I'll assign them a whole section. I'll tell them to prove that you read it. Make sure that you submit all the reading exercises.
Ah, okay.
So it's kind of because if you assign them to read something, they'll read it. Most of the time they'll read it, but they won't retain anything. They'll just read it.
How do you get them to do that?
So, but that's why I think the reading exercises are very, very useful, because I ask them, I tell them, like, you have to submit those reading assignments or reading exercises as while you're reading it. And I essentially refuse to help them. They'll email me and ask questions, and I'll just look it up.
Okay.
So, and they'll be forced. They don't like me much at the beginning of the semester. They get to like me. They grow to like me later, but there's usually a little bit of resistance of because I assign them reading assignments in math, and they're just not really open to that idea.
Okay. Maila, did you use any of the projects in the class?
Yes. The chemical kinetics one, I actually embedded them in lesson number 4 or number 3. The one about hydrogen peroxide and butadiene. Yes, they're all because they are great. I asked them to do like curve fitter to do the data fitting. So I actually skipped those parts about parameter estimation. You have that, I think, in chapter 3. Yeah, I skipped all of those parts because we were using MATLAB's curve fitter, and so we can focus more on the other models. And so you have a big chunk in what was that? You remember what I'm talking about? I think it's chapter 3, numerical methods. Yes.
Curve fitting or
and parameter estimation.
Yeah. I mean, so I tried to write it so people can take it or leave it according to what they have time for. And if you leave it, no great harm done.
Yeah.
But if the students see it, they can use it later on to some advantage. But it's a delicate balance.
But as you know, many students don't read textbooks. And so when I
know I wondered if,
And so at the Academy, we grade the homework assignments using GradeScope. So this is GradeScope. Yeah. So what I do is to force them to read the textbook. This is already the students' view. So to force them to read the textbooks, for example, question 8, classifying SMDs. And so I took a screenshot of page 138, and then I have there a lot of follow-up questions on how to determine whether a system is over, under, critically, or undamped. And so in that way, I intentionally integrate many parts of the textbook into the lesson to force them to study. And then in class, I keep on nagging. Do you remember page 125? Yes.
Okay. That's funny. Were there any other topics you skipped that were just not possible to cover?
I skipped dimensionality.
Okay.
because this topic was covered in our calculus classes.
Okay.
The parameter estimation, what else did I skip? I love the resonance.
Okay.
I love that. I think that resonance section was presented in a better way than the traditional ODE textbooks.
Okay.
Your discussion on resonance is, I think, easier to understand
Okay.
than the ones than how like Zill presented it.
Okay. Okay. Good. AJ, anything that you left out deliberately?
Deliberately, let's see. So we do talk about resonance. We don't get into the second half of the section where we get into perturbation and stuff and these kind of things. So students can, like, at that point we do cover parameter estimation in a lab.
Okay.
So that's all on the students, I think, and they get it. They like it. Can't think of anything off the top of my head right now that we skipped. We reduced how much time we spend on control because we just didn't have the time for it.
Yeah, that's one of those sort of icing on the cake topics I threw in that I do it sometimes, and sometimes I don't have time.
I personally love it, and I kind of inject it into the semester. Like every problem I talk about, it's like, what if I wanted to add more salt here, but I wanted to control it to a point. So I keep sort of injecting the whole concept of control in every model. At least talk about it, and then kind of send them the link to your video. There's a video of you. I think it was from SIMIODE maybe last year or the year before.
Okay.
There was a presentation. It was on SIMIODE. It was you talking about control.
Okay.
And then I
I don't
showed them
even
the slides. They showed them the slides that you shared with us when you came on campus.
Yeah. Okay.
And some students really read into it, love it, and I think they benefit when they go into, especially in electrical engineering, they actually have to take differential equations and take a course in control.
Okay.
Which they uniformly do really bad at. But now I think they're much better prepped to do well in that course. And traditionally, that course was kind of just a big hump, and students just had to grind their teeth and hate their lives and just read night and day about it and not understand, just go through it and get a D and move on. But now they actually see how important it is.
Okay.
Yeah,
Oh,
yeah,
good.
yeah. And Kurt, I also appreciate that you put in the Hartman-Grobman theorem instead of the picture. You know, like when analyzing the stability of an equilibria.
Yeah.
In standard textbooks, they have the trace versus determinant plane.
Oh, yeah.
Textbook, you use the Hartman-Grobman theorem. I think that's easier for many students. Previously, I was using the trace determinant plane. For many students, they understand the idea, you know, like the transition from linear to nonlinear systems using the trace determinant plane. But I think the Hartman-Grobman theorem approach is better.
Well, that one is independent of dimension, right? It works in any dimension.
Yes, and besides, we were close to running out of time, and so with the Hartman-Grobman theorem, it was like an easier way. Okay, now you know the linear. How would you understand the stability when you're looking at the nonlinear system?
Okay. Very good. Is there anything, by the way, while we're still here, that should be in the book that isn't?
Oh.
I've actually heard from colleagues that they'd like you to write the partial differential equations book, so we can use it for our PDE class.
There's a guy here at Rose that has tried to pitch he and I writing a PDE book together, but I don't know.
I know it's a big endeavor to take on, but honestly, I like the approach. It's very different than a traditional. I used Zill book and I used other differential equations book over the years. I used Zill book, I think, the most over the years. We didn't use the one for engineers. We used the one with the applications and modeling.
Yeah.
So that one actually has a bit more emphasis on the modeling, but he does it after the fact. So we do all these grinding and all this complete approach, and then there's a section at the end of the book that has all the models kind of stacked on top of each other. which most of the time we don't get to because we don't have the time.
Yeah.
So-
See, what I like, the only way I always try to teach it, there's a rhythm. Introduce the model, and maybe develop the differential equation and say, we don't know what to do with this. Let's study some math and then come back and figure out what we couldn't figure out before, and then say, okay, what conclusions does this model yield?
Which
And
I
then
think is the
maybe
I
refine
think
it.
that approach of setting up and circling back
Yeah.
is really good for the students to retain the information on long term, as opposed to a linear grind, because students will stack the information up and then forget everything and remember the last couple of things they studied. But circling back and keep doing that while the semester goes on is, I think, very, very useful. I will say that we started using models as a motivator also for Calc 2. We did take small chunks of the book. We reduced the level of the language a little bit, but we're using that as also in Calc 2 as a motivator for why do we even learn how to integrate? Well, because everything in life moves and everything is a differential equation. So we need to solve these things. Those require integrals. So that actually has been very, very helpful. And I believe our colleague Adam Rumpf gave a talk about how we introduce models in differential equations, differential equations model in Calc 2. And we didn't really see immediate results in Calc 2, at least as I know. But we're seeing the results in differential equations right now. Students love the approach. They learn better. They retain information better. Last semester, they taught differential equations in Calc 2. This semester, I'm teaching those same students in differential equations, and I can't tell you how happy I am in the class.
Oh, good.
It's really nice. It's fun. We get to talk about the complicated stuff and kind of stretch their minds a little bit, make them think a little bit, and it's really nice. We don't get to do that often, so it's nice.
Okay, good. Anything you want to think needs, Maila?
I'm okay for now.
Okay. Some
Yeah,
people have suggested I should write a section on series solutions to DEs, which is a traditional topic. We never do that. Actually, I'm taking suggestions. It's hard to find a good motivating application of series solutions until you get to PDEs and you need Bessel functions.
Yeah.
yes.
Prior to that, you see, if you want to do series solutions, you don't want to start with nonlinear equations. It's a mess. You want to start with linear equations, but linear equations, trying to come up with good linear equations, if they're first order, you don't need series. You just do an integrating factor. It's not a compelling solution technique. Second order equations that need series, well, Bessel functions, but it's hard to come up with good. I don't know. It's tough to come up with really, really compelling, non-artificial problems that require series solutions until you get pretty far down the road.
Yeah, we had the same problem trying to motivate series using models and differential equations in Calc 2. We ended up having to use Bessel function. We just didn't tell them these functions are called Bessel functions. And I think our colleague Adam Rumpf kind of meshed something together, and it's not realistic, but it's not real, but it's real looking. So students kind of as a teaching tool, it was very good.
Okay.
As an actual model and differential equation, it wasn't all that great because I don't think it's very real. But it's like you said, it's very hard to introduce. Now, what I would think is useful actually, because linear algebra is not a prerequisite for differential equations, and most students don't get to understand eigenvalues and eigenvectors until the very end of linear algebra most of the time.
Yeah.
So if we're going to talk about systems of equations, students are usually confused, and we have this unfair, so we have this population of students, and I've had this every semester, we have this unfair advantage for students who already did linear algebra for differential equations versus students who had no idea that you can actually stack equations on top of each other and solve them all together. So that's always kind of, we decided we're not going to cover systems of equations because we cannot sort this unfairness. And then and there is a suggestion now of moving at least a small portion of differential equations, very simple ones, into the end of linear algebra, where they solve systems of equations, and because at that point we know that almost all the students have had differential equations. So at least we introduce it in our courses, but it's not in the differential equation environment. So what I would not like is kind of a more, so you have a bit of a review at the beginning of the systems chapter. If there's a way to expand that a little bit to include more linear algebra so that they understand a little bit more about eigenvalues and eigenvectors before we get into solving systems of equations, maybe that'll be easier to incorporate in our courses. Does that make sense?
Yeah. Yeah. Huh.
I'm not really sure
So-
about how it is in other schools, but it's always been a challenge for me since I've never taught differential equations where linear algebra was a prerequisite. So that's a big problem.
Okay. Okay. Anybody else want to say anything? Has anyone else used it?
Well, I've been using it along with AJ. So.
Oh, you have? Okay.
Yeah, I worked for AJ.
Okay. So do you second his opinions?
Yeah, I've been keeping him honest. I'm right with him. I think we've had a lot of these conversations. You know, I agree with the whole modeling first approach. I think it just gives the students a nice general framework to kind of plug everything into as they learn, as they go through the course, instead of just a bunch of, you know, an itemized approach. It gives them a nice scheme.
Yeah. I should point out that I've never taught out of the book myself. I mean, officially, no. Everything in that book is stuff I've taught in class, but Rose-Hulman has not adopted that book yet. And I'm staying out of it.
What do they use at Rose-Hulman?
They are using this book, but from the MAA by Virginia Nunberg.
Ah,
Yeah,
yeah.
it's a nice book. Although they're thinking of, they've debated going to my book, but things have been so busy in the department with other things, they just haven't gotten around to making a decision on it. And it's since I'm officially retired, I'm staying out of it.
I like that book too. Sometimes I use that book also for extra reference. Oh, I'm sorry, it's a blur. But this is the AMS ODE textbook.
Okay.
Yeah.
Okay.
By Barbara McClure. It's also nice, but I think our students are not ready for this. But I think what worked well in my at the academy is that I integrated, I have this, I hope, seamless integration between MATLAB and the textbook. And so, yeah, because one of the things that the boss wanted me to make sure is that everyone is quite okay with MATLAB by the end of the semester.
Yeah.
As they transition from the basic math courses to their engineering and physics courses.
Okay. I saw when you typed your MATLAB code in, you used this, you were using the symbolic package.
Yeah. Yes.
Did the students use that then?
Yes.
Okay.
Yes.
Okay.
Yes.
When I was
And
at the Air Force Academy, how long ago was it? 13 years ago. MATLAB symbolic capabilities were using it, but it was extremely crude.
yes.
Probably more of a headache than it was worth. But now MATLAB it's decent.
Yes.
Yeah.
Yes. And so what I do is like those word problems that you have in the textbook, we solve them using DSolve, and then they're able to do a lot of problems using MATLAB. So like in a typical quiz, I have about 2 or 3 workout problems in a 25-minute assessment period. So like each word problem, like what I have just demonstrated earlier, is expected to be completed in about 7 minutes.
Okay. Okay. Brisk. All right. Anybody else have anything they'd like to add? Well, I'll be back at, what is it, 8 o'clock, I think it is. So if anybody wants to come back and make suggestions, I'm taking requests on the textbook. If there's something you want to see or, whatever, I'm game.
Okay.
All right.
Kurt,
Yeah.
Kurt, I have not been teaching for 20 years, so I'm out of it, but I've enjoyed reading the textbook and
Oh, good.
supporting it.
Thanks.
Mhm. I'm
Thanks.
glad
Yeah,
to
I
meet
hope it
you.
furthers Brian's SIMIODE cause a little bit in some way.
Okay.
All right. I've got to go do something, but I'll be back at 8.
Thank
Okay.
you.
All right.
Thank
Very good to
you.
see you again,
See you
Brian.
all later.
Good. Take care.
Thank you. Nice to meet you, AJ and Justin. And
Very
hi,
nice to
Beth.
meet you, Maila. Take
Bye.
care, everybody.